Hey guys, welcome to Cyber Hashira. I hope you're having a good time. Today I'm going to show you how to generate key pairs using OpenSSL. In my last video, I talked about generating secret keys and then using them to encrypt some data. In that video, I also talked a little bit about generating RSA-based key pair. Well, today I'll teach you how to generate different types of key pairs and go over some important details. So let's dive into it. Alright, I'll do a quick recap of the commands I used in my last video to generate RSA key pair. So if you run the command OpenSSL gen RSA, this would generate a private key of size 2048. 2048 is a default bit size for RSA private key in OpenSSL. If you want to generate keys of a different size, you could, let me clear the screen first. So you could just specify the size of that key. So let's try 1024. And this is RSA private key of size 1024. Similarly, if you want a key size of 4096, and this is how you generate. You just specify the size of that key and it will generate the private key of that particular size. Although the size that you define here, it should not be less than 512. So for example, if I execute the command OpenSSL gen RSA 512, this would generate a key of 512 bit size. However, if I specify a size less than 512, I should see an error message. And here's the error message. It clearly says key size too small. I can output the private key to a file. So if I do gen RSA, OpenSSL gen RSA, and I just need to type the name of the file. So I'll name it rsa.pri. And if I do ls, here's a private key. I can do cat to read this private key. Here's a private key. However, there's a separate option in OpenSSL which you can use to output the file, and I would recommend this method. So I can run the command OpenSSL, hold on, let me clear the screen, OpenSSL gen RSA-out and give it a name. So I'll name it rsa2.pri and I'll just hit enter. And now I see another file called rsa2.pri and here's the output. Now, here's the difference between these two methods. Look at the file permission. RWR for RSA PRI and just RW for RSA2.PRI. Piping the output to a file would set the default permission of 664. However, if you use -out option, it would create a file with 600 permission or read-write permission for the owner of this file. This way, the file can only be accessed by the user who created it. Of course, it's a private key. So if a user created this private key, that user should be the owner, and therefore this permission is set. All right, so now I have the private key. Now I would like to generate a public key, which I would like to distribute publicly to different people. So I would run the command OpenSSL RSA in. This is going to be our private key, so I'll name it rsa.pri, which is the private key. And if I do just pub out, it would output the public key. I can save this output to a file using -out option and giving it a name. So I'll name it rsa.pub. Okay, and if I do ls, here's the public key. Let's have a look at it. rsa.pub, and here's the public key. All right, I'll clear the screen. If you would like to examine the private key and the public key that you generated, you could use the command OpenSSL RSA in and the RSA key that we generated. So for example, I want to examine the private key. Now this would just display the base64 output of the private key. However, if I add no out dash text, this will display a text form of output for this private key. I'll hit enter, and now it's showing all details about the private key, like its bit size, the public exponent, the private exponent, everything else. Similarly, I can use OpenSSL RSA-N RSA, and I'll enter my public key file name, no out dash text. Oh, I'm sorry, I have to dash pub in. I have to use this option. So if I don't use pub in, OpenSSL RSA command will assume that the file that I'm passing is a private key, which in this case wasn't a private key, it was a public key, and that's why we are getting this error. However, if you want to tell OpenSSL that the file that I'm passing is a public key, then you would have to use this option, dash pub in. I will hit enter, and now I see the public key. The private keys that I generated were all in a readable base64 format, or I think the correct term to use here is PEM format, PEM. PEM stands for Privacy Enhanced Mail. However, if you need RSA keys to be in a binary format, then you would have to change it to DER format, DER, which is also known as Distinguished Encoding Rules. And the command is OpenSSL RSA-N. I would select the private key which I want to change, which in this case is rsa.pri. Out, I'll give it a different name, so rsa.pri.der, and I would have to add out form, which tells OpenSSL to change the output format, and the output format is going to be dir. I'll hit enter, and here's the dir file. If I do cat, obviously it's going to be a gibberish, because I will not, it's binary, so I will not be able to read any of it. So this is all binary. And if I want to examine this file, I can run the command OpenSSL RSA-N rsa.pri.der. This is the dir encoded private key. I also need to add something called inform, which tells OpenSSL that the file that I'm passing as input is of format DER. And after that, no out dash text, and this is the private key. If you are generating a private key using OpenSSL for a real use case, then it is probably a good idea to generate them as encrypted. The private keys that I generated so far were all in a readable format. To generate encrypted private keys, the command is OpenSSL gen RSA, and I can specify the algorithm that I want to use to encrypt this private key. So in my case, I will use AES-256 CBC-out and the name of the private key. So I'll just add the extension ENC just to denote that it's an encrypted private key. And obviously, if you want, you can specify the size of the private key, and I'll hit enter. Now this is going to ask me to enter a password. Enter some password. All right, the password that I entered, this password will be used by OpenSSL to derive a secret key, and then that secret key will be used to encrypt the private key that was generated. So now if I do ls, I should see my encrypted private key. Let's try to do cat on this file. pri.enc, and check this out. It clearly says that this is encrypted using AES-256 CBC, and this is all encrypted data in base64 format. And here's the command. And now I will show you how to generate a DSA key pair. To generate a DSA key pair, the steps are a bit different. The first thing you need to do is generate a DSA parameter file. So for that, the command is OpenSSL DSA param dash out, and I'll just specify a file name, so DSA param, and the size of the parameter. So I will use 2048 as the size of this parameter, and it has generated the parameter. So if I do ls, this is my parameter file, and now I can use this parameter file to generate my private key. So the command is OpenSSL gen DSA dash out, and I'll name it DSA.pri just to denote that it's a DSA private key, and I will pass the parameter file that I generated. I'll hit enter, and now I see the DSA private key. If I want to examine this private key, I can run the command OpenSSL DSA-in DSA.pri no out dash text, and here's the DSA private key. All right, I'll clear the screen. Similarly, if you want to generate a public key from that DSA private key, I can run the command OpenSSL DSA-in DSA.pri, and just like gen RSA, we have the output, we have the option pub out to output the public key, and this is the DSA public key. If I want, I can output this to a file, so I can just add out and give it a file name, so dsa.pub, and if I do ls, here's the public key. Let's do a cat on DSA pub. Here's our public key. And if you want to examine this public key, I can run the command DSA-in DSA.pub no out dash text. Oops, sorry, I always forget adding dash pub in. So dash pub in, and here's the public key for DSA. Just like gen RSA, there's also an option in gen DSA to generate an encrypted private key. So the command is OpenSSL gen DSA dash DES EDE3 CBC. So I will be using DES3 algorithm to encrypt my private key, and I'll output this to dsa.pri.enc. I'm adding enc just to denote that it is an encrypted private key, and obviously I need to pass the parameter file. Once I hit enter, it will ask me to enter a password. Okay, confirm password, and the private key is generated as encrypted format. So just like in gen RSA, the password that I enter over here will be used to generate a secret key, derive a secret key, and that secret key will be used to encrypt the private key that I'm generating. So let's do ls. This is my encrypted private key, and if I do cat DSA PRI ENC, it's encrypted using DES EDE3, which is DES3 key, and this is the encrypted DSA private key data. And now I'm going to show you how to generate ECDSA key pairs. Just like DSA, ECDSA requires a parameter. This parameter is known as a curve. There are many curves that are supported by OpenSSL, and if you want to see the list of all supported curves, the command is OpenSSL ecparam-list curves. When I hit enter, I get the list of all supported curves. Now, whichever curve you want to use, you can select it from the list. For example, I'm going to pick this one, and I'll clear the screen. The first thing I need to do is I need to generate a parameter file, just like we did for DSA key pair. So to generate a parameter file for ECDSA, the command is OpenSSL ecparam-name. I'll paste the parameter that I picked from that list, -out ecdsa.param, and the parameter file is generated. Here's the parameter file. Okay, Now using this parameter file, I should be able to generate my private key, and the command is OpenSSL ecparam-gen key-in ECDSA.param. This is the parameter file that I want to pass as input, -no out and -out ECDSA.pri. Now, the reason why I'm passing no out here is, without this command would generate a private key, and it will also include the parameter file. I'll show you in a minute what I'm talking about. So I'll hit enter, and here's the private key. Let's do cat on ECDSA PRI. So right now I see a private key. Let's try to run the same command without no out. So if I don't specify no out, the parameter file that I passed, this parameter file will be included along with the private key. So I'll hit enter, and now I'll do cat, and check this out. Here's the parameter, and here's the private key. So if you don't want to generate keys like this, you can simply pass no out, and you should get a private key with no parameter. All right. Let me rerun this command with no out. Okay. Perfect. I have the private key. There's also a way to generate a ECDSA private key without generating a separate parameter file. So for that, I'll do, one second, I'm gonna get the list of curves. So I'll pick this one. Okay. So the command is OpenSSL ecparam-gen key-name, and I'll simply paste the curve ID or the curve name that I selected from the list, -no out -out ECDSA.pri. Hit enter, and we have the private key, and here's our private key. Now that we have our private key, it's time to generate a public key. So to generate public key, the command is OpenSSL ec-in ECDSA.pri. This is my private key, and I will use the option pub out, and this is going to output the public key. To output this public key to a file, I will use the command or I will use the switch -out and ECDSA.pub, and this has written the public key onto a file, ECDSA.pub. Let's do cat ECDSA.pub, and here's our public key. Let's try to examine our ECDSA private key. So the command is OpenSSL ec-in and ECDSA.pri. This is my private key, no out -text, and it shows my private key. And this is the curve that I used. Similarly, if I want to examine our public key, so I'm going to run the command OpenSSL ec-in ECDSA.pub. -pub in -no out -text, and here's our public key for ECDSA. The ECDSA key pairs that I generated so far are not encrypted. So to encrypt those private keys, the command is OpenSSL ec-in ECDSA.pri. This is the private key that I want to encrypt. -out ECDSA.pri.enc, just to denote that this is an encrypted private key. And I need to mention the algorithm that I want to use to encrypt this private key. And once I hit enter, it will ask me to enter a password. And I have entered the password, hit ls. Here's the encrypted private key. Let's do cat on ECDSA.pri.enc. Encrypted private key using AES-256 CBC, and this is the base 64 data of encrypted private key. Gen RSA and Gen DSA commands in OpenSSL has an option to encrypt the private key when you are generating them. Unfortunately, EC does not have that option. A workaround is to pipe two commands together to generate an encrypted private key. So the command is OpenSSL ecparam-name. Okay, one second. I need the curve ID. So ecparam-list curves, and okay, this one. Okay, the screen. All right, let's try again. So OpenSSL ecparam-name. I'll paste the curve ID or the curve name and then gen key. And now I'm going to pipe the output of this command into OpenSSL ECAS256 cbc-out ECDSA. I'll use a different name. So ECDSA2.pri. Hit enter. It's asking for a password. I've entered the password. And here's ECDSA2.pri. Let's do cat on ECDSA2.pri. And this is the encrypted ECDSA private key. If I want to examine this file, I can run the command OpenSSL ec-in ECDSA2.pri now out-text, and it's asking me to enter the password. So I'll enter the password and I see the output for the private key. If I enter incorrect password, so I'll just enter something, I get an error because the password that I entered was not able to derive the same secret key that was used to encrypt the private key. Therefore, I'm getting a failure during decryption. There is also an alternate way to generate private keys in OpenSSL. You can use OpenSSL gen pkey command. I'll just do help. So this is the actual syntax of the command. Now, OpenSSL gen pkey command can be used to generate any kind of private key. It does not matter if it's a private key of type RSA, ECDSA, or DSA, or some other algorithm. You can generate all of them. This method is also a preferred way to generate private keys, and the keys generated using OpenSSL gen pkey are always in PKCS8 format instead of the traditional PKCS1 format. Let me show you. So I'm going to run the command OpenSSL gen pkey-algorithm. I just have to spell it right. All right, it's RSA pkey opt. So this is these are some options that I need to pass to generate RSA key. So option is keygen RSA_keygen bits, and I'm going to tell 2048. So I'm telling gen pkey to generate RSA key pair of size 2048. And obviously there's an option to output this file, and I'll name it rsa2.pri. I'll hit enter and the key is generated. So we have RSA private key. This is PKCS1 private key and PKCS8 private key. Let me show you the difference. So cat rsa.pri. All right, so this is PKCS1 formatted private key, which I generated using OpenSSL gen RSA command. You can clearly see that it has a header that says begin RSA private key, and it ends with end RSA private key. So this is an indication that it is a PKCS1 based private key. However, if I look at the private key that I generated using OpenSSL gen pkey, it just says begin private key and end private key. The information about the algorithm and other options are embedded in this private key data. There's also a command in OpenSSL to examine any kind of private key. So I can use OpenSSL, oops, sorry, not genpkey, it's pkey-in. So let's try the PKCS1 formatted private key. So OpenSSL pkey-in rsa.pri no out-text, and here's the private key. Similarly, if I need to examine the PKCS8 private key, I can run the command OpenSSL pkey-in rsa2.pri no out-text. And this is the other private key that I generated using OpenSSL genpkey command. I'm going to try to generate an ECDSA key now. So obviously I need the param. So list curves, and okay, this is the one I want to use. Clear the screen. All right, so the command is OpenSSL genpkey-algorithm, and the algorithm is ec-pkey-opt, so private key option, and the option that I need to pass is the curve. So it's param gen curve colon and the curve that I want to use. I can also pass a cipher algorithm that I want to use to encrypt the private key. So AS256 CBC, and the output is going to be ECDSA 2.pri. Okay, it's asking for a passphrase. I'll enter a password. All right, so this key is generated. Let me show you what it looks like. So this is PKCS8 encrypted private key. Let me show you what PKCS1 private key looks like. So cat ECDSA, and this is PKCS1. So we see the header, it says begin EC private key, and it ends with end EC private key, and this is obviously the private key data. However, for encrypted private key, we see begin encrypted private key, and the information about the algorithm and everything else is embedded in this data, and it ends with end encrypted private key. That's the difference. All right, I'll clear the screen. If I need to examine this private key, I can use OpenSSL pkey-in ECDSA2.pri, and I'm going to do no out-text. It's asking for the password, and here's the private key. genpkey command can also be used to generate private keys for an algorithm for which OpenSSL does not have a specific command. For example, there is no command to generate Edward curve keys in OpenSSL. So if I do OpenSSL list commands, I see that there's a command to generate RSA key. I see that there's a command to generate DSA key. I can use ec-param to generate ECDSA key. However, there is no separate command to generate an Edward curve key. To do that, I can use genpkey command. So I'll clear the screen, and the command is OpenSSL genpkey-algorithm ed25519. That's the algorithm name, and the output is eddsa.pri, and the private key is generated. If I need to examine this, I can run the command OpenSSL pkey-in EDDSA no out-text, and this is the private key information about EDD25519, or the Edward curve key. Similarly, if I need to generate a public key using this private key, I can run the command OpenSSL pkey-in EDDSA.pri pub out EDDSA.pub. Let's do a cat on EDDSA.pub. Here's the public key. And if I need to examine this, I can run the command OpenSSL pkey-in eddsa.pub pub in no out -text, and here's the public key for Edward curve. That's it for this video. I talked about and showed you various ways to generate a key pair using OpenSSL. In my next video, I will show you how to use these keys to sign some data and verify the signature. Link to my GitHub page is in the description below, and it has all my notes. Feel free to view them or download them if you need it. And as always, thank you so much for watching. Don't forget to like this video if you liked it, and subscribe to my channel if you're not already subscribed. I will see you soon in the next one. See ya.